Chip engineer. While it has become second nature to reach for a chip, each with a few billion transistors, to build a basic device, what many people don't appreciate is that in order to create that small rectangle of silicon, semiconductor design engineers are pushing the boundaries of physics and engineering. Today's chip designers must have deep knowledge in many domains, including system architecture, high-speed analog or mixed-mode circuit design, RF techniques, logic, software, semiconductor physics and signal integrity, in order to create robust high-performance designs. People with these skill sets are in short supply. The talent shortfall in the semiconductor industry is not a new one. For years, we have experienced shortages in various engineering roles, but recently the problem has worsened as the electronics sector has grown and been raided for talent by emerging branches of technology. According to a survey published by Deloitte and the Semiconductor Industry Association, SEMI, 82% of executives reported a shortage of qualified technical candidates. Breaking that down further, about 60% of companies say that electrical engineering jobs are the most difficult to fill, followed by computer sciences/software engineering, 35%, and computer systems/engineering, which was cited by 30% of respondents. The demand for these skills is coming from all directions, from growing existing markets including the IoT and cloud computing, to emerging technologies such as artificial intelligence, AI, and 5G networks. A PricewaterhouseCoopers report published in 2019 explored the opportunities for the global semiconductor market and found that the recent surge in demand for chips is mostly due to the growing use of AI. This trend is predicted to contribute significantly to the industry's overall growth over the coming decade. The demand for AI technology is driven by various industries, including automotive, big data, finance and e-commerce, and healthcare, which are expected to be the fastest-growing areas in the near future. These new markets build on the capabilities that the sector has created, so technology advances tend to expand the demand for skills, rather than replace skill sets, exacerbating the talent shortage. This leads to semiconductor engineers being poached by the broader technology market. A semiconductor engineer's skills are rooted in highly transferable aptitudes. They excel in mathematics and computational algorithms, device physics, computer programming and data analysis. If you can design a deep sub-micron integrated circuit, or architect a processor chip, or analyze the throughput of a wireless communication system, it is likely that you can do quantitative analysis and financial maths, process advanced algorithms in genetics and genomics, or understand and implement the data gathering for big data. A graduate with these skills can expect a range of other doors to open for them in the technology sector and beyond. What does it take to master the dark art of chip design? The short answer is, you need to learn how to learn. It is not uncommon for candidates in our industry to be involved in projects in close collaboration with teams of between 50 and 100 expert engineers, where they will be led and trained by industry-leading experts. Companies may take a two-pronged approach to attract candidates with the right educational and personal attributes. First and foremost is the educational aspect. Candidates must be sufficiently specialized in the field they wish to pursue as a career, or have the right foundation and an eagerness to learn. For chip design, it can be a graduate who holds the electrical or electronics engineering qualifications, and has soft skills for teamwork and collaboration. Candidates must be able to learn continuously and apply new knowledge fast, in innovative ways. To do this, they must demonstrate a knowledge-based approach to problem solving, rather than a formulaic approach. Companies are not looking for those who can grind through theory the fastest, but for those who get to the answer by using the fundamentals to take logical, yet creative steps. The successful candidates will also be confident, effective communicators, and personable multidimensional individuals, while also being advocates for the brand. They must be able to present their designs in detailed or abstract ways in internal design reviews, business assessment meetings or customer meetings, and be able to communicate complex issues with internal and external audiences. The right candidate will need to be able to work with a close-knit team. Companies rely heavily on internal information flows to support newcomers and look for candidates who possess a mentorship capability that will equip them to help other new joiners to thrive. To find candidates who have these attributes, the interview process is a vital tool to find these capabilities, using certain tactics and tests. For example, candidates are often presented with abstract circuits and asked to make deductions about them to show their thought processes. Tests can be designed so that interviewees need to demonstrate logic and knowledge of principles, rather than solving the exact parameters of the circuit itself. Tests can be designed to ensure that a purely mathematical approach is usually not possible with the information and time given. To maintain a high-performing workforce, semiconductor companies must take measures to keep up with technological shifts and remain competitive. To solve the talent shortfall, companies should approach talent acquisition, retention, and skills development with the same passion that they apply to solving complex technical challenges. After all, quality talent is required to generate continuous innovation and growth for these companies. There are proactive steps businesses can take to address this issue, starting with developing talent early and often. This is becoming the key controllable way to address the talent shortage, which is expected to continue as the adoption of technology accelerates. To develop talent, semiconductor companies must invest in actively developing and exposing science, technology, and engineering (STEM) students to the semiconductor industry. The semiconductor market is not the only one experiencing a skills shortage, so it must compete for STEM students in the face of high demand in other areas, which recruit them for careers such as data scientists, DevOps engineers, and IoT developers, where the immediate application of skills can be more relatable because the result of their work is experienced directly in their everyday lives. The semiconductor industry is now blessed with the opportunity to give back to academia. Investing there is more than just a path to groom future talent, it is also a way to ensure that the success owed to our learning foundations is reinvested in them. To expose students to the industry and seed the development of innovation, semiconductor companies must increase their investment in universities, strengthening partnerships with academia and improving collaborative opportunities such as internships and joint programs. The industry's relationship with universities helps to equip students with the opportunity to build and develop their understanding as to where the acquired skill sets will be useful. Offering longer-term internships to students while they are studying is of particular interest. In a conventional 1 or 2 month placement, there is rarely enough time for students to learn the ropes and get stuck into the work, but 12 to 16 month internships offer students a chance to truly learn skills and to put them into practice on real projects. Whatever the duration, it is critical that the employer invests in training both interns and new hires to ensure the individuals are trained for a scalable career path. Another advantage of a successful industry-academia partnership is to make sure that talented young people are exposed to, and part of, developing the next generation of technologies they already use today. Problem-solving, planning, and innovation in a team environment has proved vital to bridging between the theoretical and tangible aspects of everyday life and ensuring a constant stream of top-class talent stays motivated and interested. And, last but not least, successful businesses attract talented people and maintain and retain them by demonstrating the deep impact of the industry and portraying its value to business and society. It gives them an opportunity to be a part of it, creating personal growth and career development opportunities, offering competitive salaries and benefit schemes, and ensuring that employees feel happy, engaged, and involved in strategic and important work. Learning the art of chip design is an opportunity for a fulfilling and varied career in a sector that is changing the world.